question they are saying that a two-dimensional motion, the instantaneous speed is v naught and which is a positive constant, then which of the following is necessarily true? What does the necessarily true mean? Means in the given options, we have to identify the options which are always true, okay, which are always true and which hold for every time in the whole motion, particle motion. So what does the two-dimensional motion means? It means that the particle is performing its motion in a plane. It can be xy plane or any other plane, and its motion is restricted to particle's motion is restricted to a particular plane. And they are also given that the instantaneous speed is v naught. So we know that whatever the instantaneous velocity, its magnitude is always equals to instantaneous speed. Means always the magnitude of instantaneous velocity gives instantaneous speed, or instantaneous speed is actually equals to the magnitude of instantaneous velocity. In the as we know that instantaneous velocity is a vector quantity, it possesses both magnitude and direction. In the question they have given information about the magnitude, instantaneous velocity magnitude, but not about direction. So we can suppose that the particle is moving in any possible direction with a constant instantaneous velocity v naught. Okay, it is moving in any direction, we are supposing that. So average velocity is not zero at any time. So in order to understand that, let us suppose that particle is moving with velocity v naught, instantaneous velocity v naught for time interval t, and at particular instant it has changed its direction, which is opposite to the previous one. So its velocity becomes minus v naught, and it is moving with velocity minus v naught for time t. Then if I find the average velocity over the total time interval 2t, then average velocity is found by total displacement by total time. Here the total displacement in the first case is v naught into t, plus in the second case is it is minus v naught into t. So I get v naught into t minus v naught into t by total time interval I have considered is 2t. So I can get that the average velocity in this case is 0. That is, the average velocity can be 0 at any time. So option A says that average velocity is not 0. Is it true? Yes, it may be not it may be not equals to 0, but it is also equals to 0. So average velocity is sometimes equals to 0 or sometimes it may not. So option A is wrong. Coming to option B says that the average acceleration must always vanish. So considering the same case as above, let the particle is moving with the velocity v naught for time t, and it is for particular instant it is changing its direction opposite to the previous one and moving with velocity minus v naught for the same time interval t. Then the average acceleration, if I find the average acceleration over the time interval 2t, I get that the v final minus v initial by t delta t is equals to v final is my minus v naught. So minus v naught minus initial velocity is v naught. So minus v naught by 2t over the time interval 2t. So I get that minus 2 v naught by 2t is equals to minus v naught by t. So I can observe that the average acceleration in this case is not equals to 0. It may be 0 in some time. So that case is if the particle is moving with velocity v naught in particular direction, and for time t it is moving without changing its direction and magnitude, the particle is moving, then in that case if I find the average acceleration over the time interval delta t, I will get the v final minus v initial as 0. That is, average acceleration over this time interval will be 0. That is, there is a possibility that average acceleration can be 0 or cannot be 0. So option B says that it is always 0, which is wrong, which is not necessarily true. Coming to option C says that the displacement in the equal time intervals are equal. Displacements in equal time interval are equal. What does it mean? As we know that displacement is a vector quantity, so displacement possesses both direction and magnitude. Okay, it has both direction and magnitude. So let us suppose the particle which is moving in the plane, it is moving with a velocity v naught in a particular direction for time t, and it has changed its direction to this right direction for with velocity v naught, and it is also moving with for the time interval t. Then in this case, if I find the displacement in the first case, I get d1 is equals to v naught bar into t, and if I find the displacement for the second case, that is v naught bar into t, you see that the both the displacement obtained have the equal magnitude, but their directions are different. In the first case, its direction is different, and in the second case, its direction is different. So we can say that overall we can say that whatever the displacement it is obtained in the equal time interval, the equal time interval we have taken already, we have chosen equal time intervals. So displacement obtained in the equal time intervals are not always equal. Okay, so option D is also not necessarily true. Coming to option C is not necessarily true. Coming to option D, equal path lengths are traversed in the equal time intervals. So in this case, you have seen that the displacement directions are not equal. So displacements of the particles in the equal time intervals were not equal. But when we focus on the path length, the distance traveled by this particle in this direction for time in the time t is equals to the distance traveled by this particle in the time with the velocity v naught in the time t is also equal. Means the both the distance in both the cases, the distance covered in the equal time intervals are equal. So option D is correct.